Good morning, class. Good to, or at least I'm glad you are taking a look at doing these two problems here today. So this question comes, as it obviously states, from the 2012 exam. I remember my students actually doing this one and going over it. So let's just get right to it. It says a recent report stated that less than 35% of the adult residents in a certain city will be able to pass a physical fitness exam. Consequently, the city recreational department is trying to convince the city council to fund more physical fitness programs. The council is facing a budget constraint and is skeptical of the report. The council will fund more physical fitness programs only if the recreational department can provide convincing evidence that the report is true. The recreational department plans to collect data from a sample of 185 adult residents in the city. A test of significance will be conducted at the significance level of 5% for the following hypothesis. The null hypothesis is the true proportion is 0.35 or 35%, just like the population. The alternative is that it's less than 0.35. So they tell you what P is, the proportion of adults. So it just says right here, oops, sorry. Love it when I forget to put it in pen mode. Again, it tells us where P is, proportion of adult residents in the city who are able to pass the physical fitness test. So in part A, it actually asks you to describe what a type 2 error would be in the context of the study. So not only do you have to tell me what the type 2 error is in context, but describe a consequence of making this type of error. Okay? So we're actually not actually doing, a state plan do conclude on this one. So in part A, we have to talk about what a type 2 error is. So if we think about what a type 2 error actually is, this is where we fail to reject the null hypothesis when, in fact, the null hypothesis is true. Now I'm writing that up here because in my answer, I need to put this actually in the actual context of the problem and then describe what's the consequence of this, okay? So when we're talking about the type 2 error here, we'd be saying something like this. The type 2 error is saying that 35%, so it's actually really kind of saying the null hypothesis is true when in fact the alternative is true. So the type 2 error is saying that 35% of the adult residents, so I'm going to kind of use this context up here, of the adult residents in the city are able to pass, a physical fitness test when in fact it is less than 35%. Now, that's just half the question. You have to talk about the consequence. So the consequence would be basically, since they actually think it is 35%, they're not going to fund the program when in fact they should, right, fund the program, because what will happen is they're going to continue to have a smaller proportion of physically fit residents, okay, in their city. So we would say something to the extent of the consequence would be and the program and the city would continue to have a smaller proportion of physically fit residents. All right, so that is just part A. So now part B, okay, says the recreational department recruits 185 adult residents who volunteer to take a physical fitness test. The test is passed by 77 of the 185 volunteers, resulting in a p-value of 0.97 for the hypothesis stated above. If it was reasonable to conduct a test of significance for the hypothesis stated above using the data collected from the 185 volunteers, what would the p-value lead you to conclude? So what's really nice about this question, question B, is you're just actually doing, okay, the conclusion part and really the last two steps of the conclusion part in doing a test of significance, okay? So the first thing we need to do is compare our p-value to our significance level and make a decision. So we would say since our p-value of 0.97 is greater than or equal to 0.05, we fail to reject our h sub 0. What does that mean if we fail to reject? Meaning, there is not enough evidence to say that the proportion of adult residents in this city who are able to pass a physical fitness test is less than 0.35. All right, so that's all you had to put for part B. All right, last part, part C. Part C says, describe the primary flaw in the study described in part B and explain why it is a concern. Now, hopefully, when reading part B, notice how it says, okay, if it was reasonable, okay, to conduct the test. They're making you to say to make this conclusion. But many of you probably read this and thought, oh, there's something wrong with this, the way they did it. They didn't do a simple random sample. They actually asked for volunteers, okay? And because they're asking for volunteers, okay, this can lead to bias. Because if you think about it, people are volunteering to take a physical fitness exam. If you're not in shape, more than likely you're not going to volunteer to do it, okay? So the people who are volunteering to do it, okay, are more likely in shape, which causes the results to be much better than if you just took a simple random sample. Okay? Likewise, if I was in physical fitness shape, I might have a desire to want to show people in the city that I can actually pass this test. Okay? So in this one here, we just want to note our sample, okay, was not a simple random sample, but a volunteer, but I should say subjects volunteered to be in the study. This leads to a voluntary response bias, meaning those who are volunteering are most likely, in better shape and are wanting to take the test, leading to an overestimation of the true population proportion. Population proportion. All right, so that takes care of that question. Just to kind of note here, notice how, type 2 error, that's coming from chapter 9. Conclusion, chapter 9. This bottom one really is, partly chapter 9, but partly chapter 4 also. All right, let's take a look at the one on the other side. So on this one here, it says a researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same car model. Using information from the county tax collectors' records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealership. The process was repeated for a total of 8 randomly selected car models. The purchase prices and the differences, woman minus man, are shown in the table below. Summary statistics are also shown. Okay? Dot plot of the data of the differences are shown, which is actually really nice that we actually have the graphs too, because that's going to, as you can see, probably save us a little bit of work. Okay? So, in this one it says, do the data provide convincing evidence that on average women pay more than men in the county for the same car model? Okay? So the biggest thing here is they give you a lot of information. And the key thing here is we have to make sure we define our variables correctly. So, and what we're actually going to analyze. Now, notice how it says price differences. So this one is really like a matched pairs t-test. So it's like looking at that problem dealing with the grocery line where the two girls were looking at whether or not the express lane or the regular lane was faster. You want to do this one in the same manner. So we're looking at the difference data here. Okay? So everything else, okay, we're not even going to look at in here. So this is the data that we're going to specifically be using, this mean and standard deviation when doing the t-test. And this is the graph of the data, which corresponds to that bottom graph. We got to keep on going a little bit here. Down here, that we're going to do in our problem here. So, when we want to do our state plan do conclude, so I'm going to kind of keep on doing it down. You can do it on the other side right next to it. It's just easier for me to keep on scrolling down. So I need to do my state plan do conclude. So I got to write my null and alternative hypothesis. Okay? The null hypothesis, I'm going to use this mean of D, is that the mean of their differences, man minus woman, is equal to 0. Okay? So I'm going to define what the mean of the differences actually equals here. Okay? So this is the population mean difference in price. And so it's important that I'm defining it as woman minus man like they did. For the same car, of the same model, sold to both by men and women at the dealership. All right, so what we're saying is that this mean difference between the prices of these exact same cars and from the exact same dealership is 0. That they were exactly the same price. Okay? Now we're trying to show to see is there statistical evidence that women were charged more, so that the mean of their difference is greater than 0. All right, so that takes care of our state. So now for the plan, I'm going to write down, we will do a match pairs t-test for the differences of the mean. So for their mean difference. Okay. So now we go through all of our, move that up a little bit. Didn't need to move it up that far, sorry. Slide this up just a little bit. So we need to go through our conditions. Random. So what I can say is a simple random sample of 8 car models was taken. So that checks off. So for normal, okay, n equals 8, okay, which is less than or equal to 30. So the central limit theorem does not apply. Okay. However, this is where the graph comes and helps us out here. So this graph right here is what we're going to refer to. Notice how we don't even see any outliers. It's actually fairly symmetric. No outliers or skewness. So we will assume that our sampling distribution is approximately normal. Okay? So we'll say, again, so central limit theorem to, however, our dot plot, whoops, I forgot the word dot, of our differences shows no outliers or skewness so we can assume our sampling distribution is approximately normal. All right, independent. Okay. So for independent, we just need to check, is the population greater than 10 times our sample? Okay. So is our population greater than 80? So in this case, we'll say yes. We can assume there were at least 80 cars in the, and really pairs of cars, in the population to choose from. All right, so now, state plan, now we get a do, and then we get to do the conclude. So with the do, we're calculating out a t statistic. So again, t is found by taking your sample mean minus the mean of the null over the sample standard deviation over the square root of n. So if we go up top again, the values that we're using, just kind of scrolling up top here, are these two values for our mean and our standard deviation. So that's x bar, that's s. So my t is equal to 585 minus mean of the null, which we say there is no difference. The sample standard deviation was 530.71 divided by the square root of 8. So if I calculate that out, the top number is 585 divided by, make sure you put this bottom part in parentheses, because if you don't, it will calculate it out incorrectly. By the square root of 8. Close my parentheses. So there's my t statistic, which is 3.118. So now, to get my p-value, okay, we go TCDF from 3.118, okay, to infinity with the degrees of freedom of 7. Remember, degrees of freedom, n minus 1 here, so 8 minus 1 is 7. The reason why I'm doing greater than, think about this, my test is to say, I'm assuming it's 0. I have 3.117 or more, I'm doing a greater than test. So if I calculate out this p-value, so if I go second FARS, so go down to number 6, TCDF, 3.118 to the upper 99, my degrees of freedom is 7. I paste that in there, and this gives me my p-value. So my p-value, wow, pretty small, equals 0.0084. If I go out 4 decimal places. So now I just have to do my conclusion. So my conclusion would first start off by interpreting what that p-value means in the context of the problem. So I would say our result, whoops, I started to reject it. I got ahead of myself. Our result, or a result more extreme, would only occur 0.84% of the time from a sample of 8 cars if the null hypothesis was true. Since 0.0084 is less than 0.05, okay, we reject the null hypothesis. Okay. So what does that mean? Okay. That means we have statistical evidence that women pay more than men for the same car at the same dealership in this county. Woo! Alrighty, that takes care of FRQs for Chapter 9.